Alright, hello. This is an experiment with 220 volts. Here is the wire going to this switch and going to this little board that I made. Yeah, I can show you very quickly if he is focusing. I think you can see the flickering. I'm not sure if this device is getting the flickering. This is the same. I have a white LED here implemented in this little switch, and is the same circuit, like is one of these circuits. I think is this the reversal parallel with the diode in the reversal parallel. So what I have here is I have two testing circuits. I'll have to use my left hand, or let me switch the other. All right. Let's see. It's very basic. It's a 220 volts alternative current on this two. Let me bring everything actually in the same place. It's powered off from that switch, not from the plug. I didn't unplug it, and I have to be careful while filming. So I have a resistor. Here in the schematic you can vary this resistor from 1 kilo to 200 kilo, but I choose 100. Let me unplug it actually, take it out. So let's see. Nothing works. So there, come on, focus. There is 100 kilo. There is by comparison, let me show you actually all the so this is the 1 kilo matchstick box that I repurposed for well, I have four of these. See there, 1, 2, 3. This is the fourth. Well, that's the first one. New. This is a brand new resistor. It's a 1%, and this is another brand new 5%. And I wanted to see exactly if I'm doing this. It's the same size. It's 1/4 wattage, the power of the resistors, and it got interrupted. So it's 250 milliwatts power. Every resistor that I use here in the circuit. So I put it side by side to see that is the same size. And let me take out everything, and to see that I don't use more powerful resistors. That's the purpose I did this comparison with my stock that and you can see I have everything. I have is 250 or 1/4 watts, 250 milliwatts power resistor. I don't have 1 watt or 2 watts resistors, because these ones I have new ones, and I have a lot of scrap ones, and those that are that I scrapped are also 1/4 watts. And yeah, it's just I have so many. I don't have all the space in the world. I have a very limited space to put everything. So yes, that's the resistor problem that I started a thread, well, 2 threads actually, on 2 websites, on 2 electronic websites. All About Circuits is one of them, is one website, and the other one is electrical circuits, I think, and or electrical forum. It's a UK English, and the all about circuits, it's American, I think, but there is everybody there. Yes, and I got very nice comments from everybody, and we will discuss about that later. But first, let me present to show you the circuits that I made here. And so this is A, and this is B. So you see here A and B. So this is first, is exactly like I draw it here. This is the resistor, this is a diode that is pointing up, exactly like in A side here. And this is the LED, this is exactly like here in the reality. And also the B circuit in series, everything, the resistor in series with the diode, in series with the LED. And here is the arrangement, or the plan actually, the resistor, the diode, and the LED. And here is the same thing. This is actually the second, but let's say it's first arrangement with 1N4148 diodes, as you can see here. I tested it, so I will plug it again for the unbelievers. It's already started, and yep, it's working. Nothing is fumigating because I had a problem. That's why I started those. I forgot about this little detail about 100 kilo or more, actually, to 200 and even more than that. I put 10 kilo, and the current was too high for the resistor, and the resistor fumigated. Well, burned. I burned a couple of them. I'm not sure. No, I destroyed them totally. I don't have them anymore to show you, unfortunately. The burned experiments that I did. It's a bit late. I just throw them away. I should have kept them to show you the burned, but the idea was they were 10 kilo, and I did the test only for the reversal parallel. All the tests I did only with this circuit, but now I'm doing the same test with both of them, because I took some measurements with my new acquirement of this super cool device. It's a thermometer, and I cannot operate it at this point because I have to stay with the hands in a special position, and I cannot keep the phone in the hand in the same time. It's just impossible. And also I have 220 volts exactly, 240 volts exactly on this bar and exactly on this bar, so it's very exposed, everything to mains. I don't want to risk it, so you have to believe me what I'm showing you here. So the resistor is 1 kilo in both of them, and for this circuit that I have here, so the first one, that one, I should have noted it A and B to be more clear. I didn't. So I have 90 degrees Celsius. This device is in Celsius, which is should be which is correct, and 100 over 100 kilo over that resistor. Let me point with something else. Over that resistor, I have 90 degrees when I had 1N4007. I actually have them here on the table next to me. I test them first, actually, these ones, and then I switch to 1N4148 the diodes, and I took the measurements because I was curious. I was very curious if if indeed is more they are getting more temperature, these smaller ones, than the more higher voltage rated 1N4007. These are for 1000 volts, and these ones are for, I don't know, I don't know. But they are smaller voltage rectifiers than 1N4007. So that's the curiosity, if it's correct or not correct to use this 1N4148. And I took the so for 4007 it's 50 degrees on it, and 4148 is 50 degrees on it. I sometimes I'm getting let me show you actually, because the probe, the temperature probe that I'm using here, you see it's a small dot, it's a small welding actually, it's a probably thermic, it's spot welded, I'm not sure, but that's the temperature between two different wires, different metals, metallic wires. That's the trick of taking the temperature, and that small thing over the entire surface of the component, I get different results. Probably where the track, you know, it's like having tracks. A spiral is a spiral. Inside the resistor, I mean, not inside the diode. So inside the resistor is like a spiral, and in some points I get a little bit more higher voltage. Here is 94 for the resistor, and also 50-50. So for the second one, the second circuit, let me point with something else, with a plastic thing, and this is the B circuit. This is the B circuit in series, when everything is in series, and on the resistor is getting 50 or 56. I'm not sure. It might be instead of 50 also 50 something, more than 50 a little bit, but it's around 50. And when using 1N4007 and 40 degrees over the case, over the case of the diode, and here is 43, a little bit more for the 1N4147 here, and it's around 40. But the thing is, what I discovered is this is an isolator, correct? And also that the body of the diode is an isolator, not to touch the conductors and and current yourself. But when I probed, actually what I did two things. I probed the body of the component, whatever it was, the resistor or the diode, and even the pins of the LED. I took the measurements, and they are almost at the room temperature. I did a test before, and they were hot, but probably the heat was going. They were all too close together, and the heat was going very easy to the pin of the LED in my tests that I did before. But here, when everything is completely in air, it's the temperature is very close to room temperature, which is excellent. So back to the idea that I was trying to tell you. When I took the temperature over the body of on this isolator, it gave me these results that you see here, all this. But when I took the measurements on the metal very close to the end or the beginning of the component on its legs, but very close to the internal contacts that is happening there, the temperature rises with 5 or with even 10 degrees in some cases, especially for diodes. I think because the resistor is very hot, it got the temperature got from the resistor component, migrated the temperature into this metallic pad here, and then into the leg of the diode, and that's why I was getting a little bit more higher temperature there, and even on the other side as well. But that's a small detail. I was very curious about how much they will heat up, and how big is the difference between using two different diodes, especially the 1N4147, which is not actually is not recommended. Is recommended to use 4007. So I think if it's a closed case, if it's a case that is enclosed, all the temperature from the resistor and even the diode itself, they will influence each other pretty much. Even it will influence the temperature of the LED if they are very close together. What? Did you move? Didn't move. Just trembled. But here, when everything is experimental in air, everything is kept at a lower temperature, and they are not influencing each other that much as it is here in a very enclosed space, where they have little space to breathe and to get thermal dissipation, you know, and they will hit each one on each other, and they will influence the temperature on each other. But pretty much in this experiment is telling me that well, it doesn't matter the diode. What I am very happy with is the B experiment. This is the second experiment when everything is in series, and I get a very low, and I get a lower thermal dissipation on the resistor comparative with the first experiment, and that was the discussion. Actually, somebody told me, explained to me very extraordinarily good. Extraordinarily good. He explained to me, and I really like it, and that's why, because of him, I made this video. Of course, I made first all the tests, and now I made the video because why not? I want to show him. So he was right. I mean, the idea was that the wave, I hope I have time to explain this last point. The 240 volts is two waves. Is alternating, yes, is one up and one down, alternation, and only this resistor is seeing two alternations of the alternative current, while this resistor is seeing only one alternation, only 120 volts, because this diode logically and very clearly is breaking the other half, is stopping it, and is not permitting anything to get into this resistor, while this one is getting both halves, and is very is not that good, because it in one cycle will light the LED, but in other cycle will just waste energy, and it's very wasteful. And the temperature on it will rise double. It will be double than in this single, and it's actually the temperature that I took, the experiment that I made here is actually showing me everything that is correct. And yeah, it's a fantastic experiment. It's a good experiment, and yeah, I hope it will help others, especially if I'm making it public and on YouTube. So there is clearly a better circuit. The B circuit is better than the A circuit, which is in parallel, reverse parallel. The diode is, and this is in series. Everything in series. The B, this is better. The temperature over the resistor is lower. It's 50 degrees Celsius than the reverse parallel one, which is double, 90 degrees. And over the diodes a little bit lower, but I believe the temperature on the diodes are influenced by the temperature from the resistor. Actually, the diode will not get hot that much by itself, but they are influenced by the neighborhood components that are getting hotter, which is that resistor. So the B circuit is the winner. All right, I made a second test here. These are the original LEDs that you've seen the first time. I have other LEDs here, and these are I call them new LEDs, but who really knows what they are? Definitely these white ones, cold white, they are very different technology for a LED than the old technology of the LEDs that we all are accustomed with, and we learned from books about this type of LEDs, this and this. Unfortunately, I have this 5 millimeters, and the rest are 3 millimeters. This one 3, 3, 3, 3, 3 again. These are 5. These are 5 also white LEDs, and this all of them are new LEDs. New, like from 2015 up, and these are the old LEDs, old type of LEDs, which I purchased them and I keep them from, I don't know, 1995 maybe. And they are I just look on Wikipedia, and you will see what I've read already. I read about there are 2 types of technologies, well, maybe 3 types, but the 2 major types of technologies for LEDs are the old type, which is gallium arsenide, which are this old, from the 80s, 90s batches of LEDs. And let me get you one to show you. They really don't look different from the new ones. They kind of they don't have too much visible differences, you know. But the way they are lighting up, the new ones are super bright, and these old ones are bright, but usually are much more dimmer than the new ones. And the new ones are getting a range of currents way more bigger than the old ones. The old ones are very limited for the currents they work with, the gallium arsenide. Actually, I write it down here. Gallium arsenide, this is how it's written, and gallium nitride. These are the new ones. The rest of them. And this one, the white ones, they have a special technology. They are also gallium, what is called? Nitride, gallium nitride, but also with phosphorus in them. If you can see, it's a white, it's a yellow. I'm not sure how better you can see, if it's focusing. Come on. Yeah, you see, it's a little bit yellowish. It's having like a surface, yellowish surface on it. You can barely see it's yellow, but I'm telling you, it is a little bit yellow. And that yellow surface is actually the phosphor. And that phosphor is amplifying, is enhancing a tone. And that's why they are called super bright, because there are many different types of technologies. They made the LEDs, and they experimented, and also these ones, also with the yellow is clearly visible here, and they are also white LEDs. These are for illumination, actually. Come on. Like that. These are for illumination, and is what I'm having here in my lamps, and on this one as well, and this one with some burned LEDs on it, which I'm scrapping it. Well, I'm trying to scrap it. So yes, that's the difference. And now I was very sure that they will not work, the old ones. These are the gallium arsenide, which are the old ones, and I was super sure they will not work. But for my surprise, they did work. So let me power it up. Well, plug it in first. Come on, and. Now it's working, which is a bit surprising. Because it's having 100 kilo there, the current is super low, and they are a bit dim. They are not at full brightness, but it's good for me. I mean, yeah, it's excellent. I suppose these circuits here, they work for older LEDs as well, from the old times, not only for the new LEDs that are, I don't know, 2010, 2015 maybe. I also have, let me focus. I also have a 10 or 8 millimeters. These are, I wanted the white ones, but they sent me red ones, and yeah, I kind of. It's exactly the same. The pins and the interior is like the one of 5 millimeters, but this the 8 millimeters. Well, it's good enough. And yeah, that's it. Thank you very much for watching, and thank you for the discussions that I did that I had with the guys there on the forums. And yeah, I hope I will continue this movie with more interesting experiments and subjects to discuss. Bye bye for now, and see you later. Bye bye.